Hey flight crew, welcome to Captain 3D Printed FPV.
The channel where we design, print, and fly cutting-edge RC aircraft, both quads and fixed wings. From beginner builds to advanced FPV projects, I share tutorials, tips, flight footage, and my wrecks to take your hobby to the next level. If you love 3D printing, RC planes, and pushing the limit of what's possible in the air, you're in the right place.
Are you new to 3D printing RC planes? Well, if you are, this video is for you.
Today we're going to start off with the Eclipson Model A. This is a free, beginner-friendly trainer that's easy to print, easy to assemble, very fun to fly, and cheap. In this episode, I'll show you where to get the files, how to read the drawings, how to set up your slicer, and then how to get printing your very first RC airplane. So first off, why the Model A? The Model A is a very well-known trainer that flies very well. It's cheap to build, easy to repair, and they claim your electronics will survive the crashes. So let's take a look at this Eclipson Model A. Oh, I forgot to mention, it's a free download as well. I said free, it's free. So let's take a look at this thing. You can see here it's safe to hand launch with the propeller being in front, or there's a model with landing gear. I would recommend beginners stick with the landing gear model. That way you can actually taxi this thing and take off, and you don't have to worry about your throw angle. This thing is purpose-built for 3D printing, meaning it wasn't just something scaled down from another model. It's actually made for additive manufacturing. This is great because it really optimizes the weight and the shape of the model. So it's nice and sleek, aerodynamic, and flies well. The next piece of this is the curved wingtips. These keep the tip from stalling or provide a little bit of resistance to stalling and makes the stalls much more docile. So instead of the airplane spinning, it just will go nose over in a docile manner when it stalls. As I mentioned earlier, it's got a smooth and aerodynamic fuselage because it was actually designed for additive manufacturing. And then we've got optional landing gear. In our project, we will be installing the landing gear. We're going to build in PLA, so we'll be installing the gear on the left with the double steel rod, and we'll be installing this push rod on the tail. So we will be able to taxi around and take off from the ground, which I find is important for a beginner aircraft. All right, that brings us all the way through why we're going to build this Model A. I think most people can probably build this for around $8 to $10 of filament if you use PLA, and maybe $12 to $16 of filament if you use some lightweight PLA. So that's it. We're going to move on here and have a look at the Eclipson website, and I'll walk you through how to download the files and unpack the files, and then we'll get into the printer settings and actually printing some parts. All right, flight crew, here we have it. We are on eclipsonairplanes.com/Model A. I know that's not on your screen, but if you just search Model A and Eclipson, you will end up at this page. So I just ran through all these images with you and talked about why we're going to build this airplane, why it's a great beginner airplane, and why it's a great beginner airplane, both if you're unfamiliar with 3D printing and unfamiliar with flying. So moving on, we can look here at the specifications. We're going to build this thing in PLA. So we are shooting for a target weight of 390 grams. Takeoff weight, including the landing gear, of 730 grams. You see there's two different stall speeds here. A lighter airplane stalls at a lower speed. So the stall speed in our build is going to be about 29 kilometers per hour. This gives us a wing loading of 30 grams and 45 grams there, as you can see. This wingspan is 39 inches, or right at 1 meter. This leaves us with a wing aspect ratio of 6.6 to 1. And the overall length of the aircraft is just under 3/4 of a meter, 760 millimeters. So to download the files, you just go down here and say download drawing. This is going to give you this drawing. We'll get back into this drawing here in a second. Okay, as I was explaining, if you want the free files for this thing, all you have to do is scroll back up here and say download free version. It says the free version doesn't include the landing gear parts, but the free version that I downloaded definitely has the landing gear parts. So let's go ahead and click over here. This is going to take us to cults3d.com, and you can see this is the free version here. All you've got to do is click download. If you don't have an account, you're going to be urged to log in, which I just logging in here. But if you hit download free version here, we've got this, and all you do is hit the download button and download. We want this download all here, and I'm going to click that. And you couldn't see it, but off my screen, I've got the Model A open here. And from there, we're going to unpack these files, and I'll get into the files here in the next segment. All right, so to open these files up, it's no different than any other archive file that you've seen before. You're just going to click on your downloads, open up the zip file, and then in the top of your screen, say extract all. It might be a little bit different depending on which version of Windows you have or what you're using to unzip your files, but yeah, that's pretty much the basis of it. So you can see in here I have quite a few STL files. There's a folder for decals, and then also a folder for just raw G-code if you're not using a slicer. But we're going to learn how to use a slicer, learn how to set up proper printer settings, and yeah, do the whole thing. So, okay, let's recap this real quick. We have now downloaded our STL files, and now we just need to understand the Eclipson plan of how they want you to build this airplane and what the associated printer settings are for this. So if we go back over here and go back to the Eclipson site, you can see I'm on this arrangement drawings and printing parameters. So the first thing that you have to understand here is each item is numbered, and then that correlates with this column here where all the numbers are. And you can see what the parts are called and so on down the road. So then next to each one of these parts is a category. This is super important, very important. So you can see there's a category C, you can see there's a category A, and then there's a category A-lightweight. Well, what this is, if you scroll down a little bit further here, you can look in the printing parameter box and see A-lightweight is going to be lightweight PLA, and then A is just going to be either PLA or PET-G, and then C-LW is again lightweight PLA, and then C is either PLA, PET-G, or flexible material ABS. And then each one of these columns has the associated printer settings. We will have to enter into whatever slicer you're using. In our case, we're going to use Orca. I'm a big believer in Orca. Check out some of my other videos on tuning your printer and calibrating your printer using the Orca method that I have in my lightweight PLA parameters video. I'll link that in the description below. Okay, so we know how to read this now. And we know how the parts are labeled. And if you look back to the STL folder, you can see that the STL folder names line right up with the names over here. So like Canopy 1, Canopy 1. Okay? There's one more gotcha here, and this is where a lot of people have problems with this Eclipson setup. You see all these little flags out here, so like 7, 9, 8, 5. So there's some notes down here in the lower left of the drawing that talk about what these little flags are. So in addition to using the printing parameter box, you also have to use these flags to make sure you're set up properly. So let's have a look at what these flags do. So 8 means add 8 bottom layers. 9 means add 2 top layers. 7, add 2 bottom layers. So if you go back up here and start looking at the like flaplorons and stuff like this, you can see we've got a 9 and a 7 on here. So let's go back down. A 9 means we're going to add 2 top layers, and a 7 means we're going to add 2 bottom layers. So I know from experience this is going to be printed standing upright. So what that is doing, that's putting 2 layers on what will be like the left side of the flapleuron, and then 2 layers on like the right side of the flapleuron. So it's actually like enclosing this part. Versus here, when we look at the wings, we've got wing 1, wing 2, left and right. These have no notes on them, okay? So if we go back down here and look at, say, A, an A lightweight, you can see this has no bottom layers and no top layers. So effectively, that's going to end the printing and leave the end of the wing segments that you're printing open, which is what you want because you're going to connect these together and you don't want a layer there. But a lot of people have problems and just start buzzing down through this list printing things and don't pay attention to these flags and then end up with parts that don't fit together. So that's a number one gotcha that as a beginner you need to pay attention to. You can't just go and run down through here and print with these same settings over and over. All right, we'll dive into this a little bit deeper and do the printer settings next. All right, flight crew, let's get into these printer settings now. As I said, you've got to pick off your printer settings from this printing parameter chart down here. But as I said, the number one gotcha is make sure you include these add-ons for each part they're going to do. So let's set up a printer profile for PLA. I said we're going to do this in PLA, so it's going to be this A column here. And we're going to go over to Orca Slicer and start putting these in. So let's just review this real quick. The layer height is saying 0.2, no bottom layers, no top layers, one wall line all the way around, nozzle diameter 0.4. Again, we're going to do PLA. So 0 infill, printing temperature 220. This, my personal opinion, shouldn't be on here. This is something that you should set up for your printer. And again, bed temperature probably shouldn't be on here. You should be doing a calibration like in some of my other videos and picking these off on your own based on your print quality. And same with flow. Your flow rate might be 101%. It might be 98%, depending upon your printer and your calibration. Same with retraction. I personally don't think retraction should be on this list. This should be something that you calibrate. And same with the extra prime amount. Again, something you calibrate. Speed, again, don't mind that it's here. I like that they've got it nice and slowed down. So, beginners are going to get good prints. But if you've got a higher end printer, you can definitely go faster than 55 millimeters per second or 50 millimeters per second. Fan, yes, we'll put that in. Brim, yes, that's a setting that they need to define. Minimum layer time, 5 seconds. What this does is it actually pauses the printer in between layers. So if the printer rips out some super small layer in, say, 2.5 seconds, the printer actually pauses and lets that layer solidify or harden a little bit before it continues the next layer. So basically, this is saying that the minimum layer time is 5 seconds. Otherwise, the printer should pause. And then every place has support turned off. This particular airplane is designed to be printed without support as long as you orient the parts correctly. Okay, so let me bring up Orca here. So if you haven't used Orca Slicer before, I highly recommend you switch to Orca. The first thing you're going to do is calibrate your printer. There's a whole other video in my series about calibrating your printer. This is super important for you. You're not just going to go and pick up somebody's printer settings off the internet and think that your printer is going to work. You got to calibrate your printer. Have a look in the description below. There's a calibration guide for lightweight PLA. Follow it, and you'll be printing like a champ. So first off, let's run down through here and start doing our settings. We are going to use the printer. It's a Creality K1 Max. This is my main printer that I've been using for about a year now. I really love the K1 Max. And then I've got Creality high flow generic PLA in here. That's what we are using. And we can look at the settings on that here by clicking this pencil button. And then in the process section, you can see I've got 0.2 millimeter standard Creality 0.4 nozzle Dustin V1. The reason that this is customized is because I've done the entire calibration process for my printer that's described in that other video. You really need to do that. You're not just going to be able to jump in and just play with some settings. You really need to do the calibration first. So watch that calibration video and do the calibration video. So, okay, if we remember, I'm going to start here on quality. If I go back, the layer height that was called for was 0.2. So that seems to be okay. 0.2 layer height, yep. So let's go and do our bottom layers and top layers and our wall. So 0, 0, and 1. So that's over here in strength. Wall loops, I'm going to take this down to 1. And you see it's turned orange here. That means that there's something that's unsaved in Orca. And all you have to do is hit the save button, and then you can rename this process for something. And we'll rename this Eclipson here in a bit. So top shell layers, I'm going to take that down to 0, and bottom shell layers down to 0. Now remember, you'll edit those on some parts, but for the first print here, we're going to do that 0 top and 0 bottom layers. Infill was 0, if you recall. Back over here, and let's go take another quick look. Yeah, nozzle diameter, that was already done. Obviously on the printer, that's not a setting. And then we are doing PLA, and then infill density is 0%, which I just set. So now it's asking for print temp 220, bed temp 60, and flow 100. So in Orca, these settings for the temps and flows are under your filament. So you come here, you click this pencil, and you go here, here's your filament, generic PLA. And you can see right now my flow rate's 0.98. That's because I have calibrated this, and that's where I got the best prints at. You can see that indeed my nozzle temp is set to 220 for this particular material, particular filament, but this should really come from your calibration, not necessarily just from Eclipson saying your filament should print at 220. You should calibrate for every filament that you're using. Then the textured build plate is set up for 40C engineered build plate, and on down the road at 60C. So that all matches up with what Eclipson is asking for over here, down to here. Retraction and retraction amount. Again, these are both set up in what you should be doing in calibration, not using Eclipson's settings. Speed 50 and fan yes, and then we got Brim. So let's go back over here. And so the fan speed is set for 100% for that exhaust fan, and always keep fan on, and fan speed 100%. So we're okay on those. And then Orca Slicer does something a little bit different. I was talking about the minimum layer time being 5 seconds. In other slicers, you can put in that time that you want to make for your minimum layer time. In Orca, it's slow down printing for better layer cooling, and you just check that. It uses its own intelligence to know when it needs to slow down to let our layer harden. So that's one little gotcha in Orca. You don't have a 5-second setting to stick in there. You just simply turn on that little flag there. So let's go back, and we'll set the support, the Brim, and the speed now. So I'm going to go back over to Orca again here, and that all is good. And you notice I didn't have to save anything, so that was already all set up. In speed, this printer is very, very fast and prints very well. But what I'm going to do is just run through here and switch this to 50 for my first layer as they recommended. We have no infill, so that's not going to make anything. This outer wall, I switched to 50. Inner wall, I switched to 50 as you recommended. Again, this doesn't necessarily have to be stuck to 50. You should calibrate your printer and understand how fast your printer can print, and print at the maximum level that you can print at, retaining quality. But just for the purposes of the demonstration here, I'm going to switch all these to 50. And then I'm going to go support. And in my support tab, you notice enable support's tagged right now. We don't want any support, so I'm shutting off support. And I'm going to leave this remove small overhangs tagged there, and go there. And then under other is where we find Brim. And we're going to do outer brim only. You could do inner brim, outer and inner, but I find this, if you do outer and inner, it makes the parts a little bit harder to trim, and that little burr keeps the parts from really fitting up nicely. So I'm going to do outer brim only. And what did it say, 5 millimeters over there? I think it said 5. Brim, 3 to 5. So I think we're already at 4. I'm going to jump this up to 5. I like my parts to be nice and secure to the build plate. And so on down the road. So let's have one more review before we move on here and go back over here. So let's make sure we have all our settings in. Layer height was yes. We got bottom layers. Yes, yes. That was already there. Yes on that. 220. Yes, yes, yes. All these were already set up during the calibration. I set everything to 50. Fan was on. Brim was set to 5. Minimum layer time was checked to wait, and we shut off support. So I have properly set up category A here, and I'm going to go back over to Orca Slicer, and you see this little floppy disk or hard disk here. You click this, and it's going to let you rename this thing. So I'm going to switch that from Dustin V1, and I'm going to call this Eclipse, or just something like that, V2, and say OK. Okay. So now you can see this has changed, and we've got our Eclipson settings here under our process, which is exactly what we wanted. I'm going to go ahead and switch back to the Eclipson settings that I use on a regular basis, just because I know I didn't make a mistake during the video. So what's next here? Oh, it's time to print a part. Amazing, huh? So let me pull up a part here. And what we're going to do is pull off, and we'll do, how about a fuselage part? We'll do fuse 2, okay? Is our example here. So first of all, I'm going to pull off fuse 2 and pull fuse 2 in. I see here it's like fuse 2 without landing gear, which that's okay. So here we have it. You can see how it's oriented itself. This looks okay to me. I think it's going to print best this way. There's really no directions on this, but that's fuse 2. So if we go back over here, remember I said there's a gotcha on some of these parts. Let's just go up to fuse 2. So fuse 2, part number 6. We can see part number 6 out here in the middle. And indeed, it doesn't have any flags beside it. Okay. So again, category A, and we just set up category A. So we should be ready to rock and roll with this thing. I'm going to go ahead and slice this plate. Say slice. And it's pretty much easy as that. So one of the key differences, you can see in prepare, this appears as though it's filled and there's a top surface there. But as soon as you go to preview, that surface goes away. That's because you don't have any top skins or bottom skins clicked in this thing. So you can look at the bottom too and see that there's nothing there. So if we go and look at this, that's literally just outer wall all the way up. And you can see the brim down there at the bottom too. So I quite like this. Let's go ahead, and I'm going to say print up here in the top right corner. It's going to say upload and print. You're going to see down here in the bottom right, everything shoots off to my printer. This is all set up through like a wireless printer connection that Orca actually handles. So there's no like intermediate software like Octoprint or anything like this. So, as I was saying, we can drop over here to the device tab in Orca and actually see what's going on with the printer. You can see it's moving up the bed right now, and probably getting ready to do its like bed leveling and analysis of the bed leveling, and proceed on down the road with the print. So there will be a time lapse of this. There'll be time lapse of all of the prints for this. Yeah, so we'll end the video here, and we'll get into the print quality and how the prints are going in the next video, and actually start cranking out parts for this airplane and assembly. And then what I'll do is I'll do individual videos showing the setups for those gotcha moments of, you know, when there's a 7 or 9 flag beside there. So I'll show how to print a flaperon and switch the Orca settings, just to make it super clear for everybody, for the beginners that are trying to get into this hobby. Okay, all right. Appreciate your time Captain 3D FPVs signing off. Give me a subscribe or a thumbs up. Leave me some comments below on what you want to see next.